Hello everyone, I'm Priyanka Shah and welcome to my YouTube channel Mathlite. In this video, we'll continue with exercise 7D from chapter Ratio and Proportion. So coming to question number 17. If 4m plus 3n upon 4m minus 3n is equal to 7 upon 4, use properties of proportion to find first part m is to n, second part 2m square minus 11n square upon 2m square plus 11n square. First, we'll write down the given. We are given that 4m plus 3n upon 4m minus 3n is equal to 7 upon 4. Very easy question. Okay. First sub part, you need to find out m is to n, that is m upon n. Uska ratio find out karna hai. Now this is the given information. Check the terms 4m, 4m. 3n, 3n. So we have same terms, and what are the signs between? Plus and minus. So whenever you are given same terms and the signs are opposite, which property you can use to find out m is to n? The ratio of the variables. It is componendo dividendo. So we'll apply componendo dividendo over here. What does componendo dividendo state? It is numerator plus denominator upon numerator minus denominator. Okay, so it is already in that form. Again we'll apply that. Okay, so it will be numerator plus denominator upon numerator minus denominator. Same thing in RHS simultaneously. Okay, so by componendo dividendo, I'm not writing the full thing, you have to write down full reason. Okay, by componendo dividendo, numerator plus denominator upon numerator minus denominator, ठीक है, is equal to same thing, numerator plus denominator upon numerator minus denominator. Now we'll open the brackets. So 4m plus 3n plus 4m minus 3n upon 4m plus 3n minus 4m plus 3n. The signs will change over here when you open the brackets. 3n 3n cancel हो गया, 4m 4m cancel हो गया. 7 plus 4 11 and 7 minus 4 3. So here we'll get 8m upon 6n is equal to 11 upon 3. We need to find m upon n. So we'll keep m upon n as it is and we'll shift 8 upon 6 on the other side. So when you shift this on the other side, reciprocal हो जाएगा. 6 will go in numerator and 8 will go in denominator. So m upon n as it is, 11 upon 3 as it is, shifting this, reciprocal. 3 2s are 6, 2 4s are. So m upon n is equal to 11 upon 4, that is m is to n is equal to 11 is to 4. Write it in this form because the question is asked in that format. Box this. Okay, so this was first subpart. Now moving on to the second subpart. Moving on to second part of the question. There is 2m square minus 11n square upon 2m square plus 11n square. We need to find the value of this. So we have 2m square, 11n square, 11n square. And normally we have plus sign in numerator and minus in denominator. यहाँ पे it is ulta. We have minus in numerator and plus in denominator. So basically we need to use componendo dividendo. Right? What is componendo dividendo? Numerator plus denominator upon numerator minus denominator. यहाँ पे it is interchange. It is numerator minus denominator upon numerator plus denominator. But what will be my numerator and what will be my denominator? Numerator will be 2m square. And denominator will be 11n square. So I need 2m square and 11n square. I need this. 2m square upon 11n square. I know m upon n, it is 11 upon 4. I found it in first part of the question. Now I need square. So what we'll do? First we'll square on both the sides. Whenever you have some coefficient and there is m square, n square, x square, y square, a square, b square, whatever, but square hai or cube hai, what will you do? You will square or cube first, okay, and then you will multiply by the respective number. So we need to first square this. mb squared hai, nb squared hai, so squaring on both the sides. You have to square on both the sides simultaneously. So m square upon n square, everything will be squared. 11 ka square 121, 4 ka square 16. Okay. Now with m square I need 2 and with n square I need 11. Here I need 2, here I need 11. So I need to multiply by 2 upon 11. Now I cannot multiply only on one side. I need to multiply on both the sides. So we'll multiply by 2 by 11 on both the sides. So multiplying by 2 by 11 on both the sides. You have to give statements, okay? So 2 by 11 into m square upon n square is equal to 2 by 11 into 121 upon 16. So we'll get 2n square upon 11n square is equal to 2 8s are 11 11s are. So we are getting 11 upon 8. Okay. Now I need to apply componendo dividendo because I need 2m square plus 11n square and 2m square minus 11n square. Okay, and then we'll use invertendo because I need minus in numerator and plus in denominator. You cannot use dividendo componendo, ऐसा कोई property नहीं है. So we always use componendo dividendo. Okay, so we'll apply componendo dividendo over here. So by componendo dividendo, you'll write the full thing. By componendo dividendo, numerator plus denominator upon numerator minus denominator is equal to numerator plus denominator upon numerator minus denominator. Okay. So 2m square plus 11n square upon 2m square minus 11n square is equal to 19 upon 3 है ना. Now I need this in numerator and this in denominator. So what we'll do, we'll take reciprocal, that is invertendo. Whenever you take reciprocal, it is invertendo. You are interchanging the numerator and denominator. So by invertendo, please be familiar with these properties. All right. By invertendo, numerator denominator exchange हो जाएगा. So 2m square minus 11n square upon 2m square plus 11n square. You're also interchanged 3 upon 19. Box this. Okay. So we found the value. It's 3 upon 19. Let's read the next question. Question number 18. If x, y, z are in continued proportion, prove that x plus y the whole square upon y plus z the whole square is equal to x upon z. There are two ways of solving. First method is K method because you are given something in proportion and you need to prove something. So you can use K method. Other method is the square of the mean, that is y ka square is equal to product of the extremes, that is x into z. You can use this method or K method. Okay, I'll solve by both the methods, whichever you find easy you can use that. First I'll use this method. Okay, you are given that x, y, z are in continued proportion. So x, y, z are in continued proportion. So what do you mean by continued proportion? It is first upon second is equal to second upon third. That is, the denominator here becomes the numerator. Okay. So x upon y is equal to y upon z. Therefore, cross multiplying x, z is equal to y square. That is, y square is equal to x, z. We'll use x, z in place of y square. okay, or y square in place of xz, depending on how you need to get the RHS. ठीक है, so we'll consider LHS. RHS तो simplified है, you will never consider the simplified part for proving. ठीक है, so always consider LHS. So starting with LHS, x plus y the whole square upon y plus z the whole square. You have whole square, so which identity? A plus b the whole square का identity. Okay, there are plus signs. So a plus b the whole square is a square plus 2ab plus b square. You are supposed to know the identities. So a की जगह पे x है, so x square plus 2xy plus y square, y square plus 2yz plus z square. Since you are using the identity, you have to give reason. A plus b the whole square is equal to a square plus 2ab plus b square. ठीक है, now instead of y square I can use xz, so let us use that. X square, so here I cannot make any substitution. Xy, so here also I cannot make any substitution. In place of y square I can substitute xz. Okay, and over here also I have y square, so I can substitute xz plus 2yz plus z square. Okay, now here I have x common, so let's take x common. What is left inside the bracket? 1x plus 2y plus z. In denominator, what can I take common? Z. So taking z common, in bracket you are left with x plus 2y plus 1z. I can cancel out the entire bracket, it's same. So cancelling the entire bracket, you are left with x upon z, that is nothing but RHS. This is what we wanted in RHS. मिल गया. Okay, so after this you will write down therefore LHS is equal to RHS, and after this write down the entire LHS and entire RHS. LHS is this, RHS is this, so this is equal to this. यहाँ पे पूरा बाद में लिखो, and after this hence proved. Okay, now moving on to K method. We know that x, y and z are in continued proportion, therefore x upon y is equal to y upon z. Okay, now we'll take these two ratios equal to k. So let x upon y equal to y upon z be equal to k. For K method we keep last term as it is. Okay, last वाला जो भी quantity होगा as it is, and first and second we'll express in terms of last one, that is x in terms of z and y in terms of z. Okay, so I'll take this equal to k, this equal to k. So I'll get x is equal to yk and y is equal to zk. Now I am getting y in terms of z, I need to bring x in terms of z. I know y is zk, so I'll substitute zk over here. ठीक है, फर्स्ट एंड सेकेंड को हम लोग लास्ट के टर्म्स में लेकर आएंगे. सो x ऑल्सो इन टर्म्स ऑफ z, y ऑल्सो इन टर्म्स ऑफ z. y मिल गया, x को भी लेकर आना है. सो x विल बी इक्वल टू z इंटू k, दैट गिव्स k स्क्वायर. So x is equal to zk square and y is equal to zk. Now we'll substitute x as zk square and y as zk in LHS. LHS is little complicated, so this we'll consider, not RHS. ठीक है? Let's see if we are directly getting the RHS. So starting with the LHS, x plus y the whole square upon y plus z the whole square. So x is what? Zk square and y is zk the whole ka square upon y is again zk and z is z only. Now I'll not square over here. Okay, instead what I can do, I can take z and k common. Numerator mein I have z, z, k, k. I can take one z and one k common. So taking z and k common, inside the bracket what will be left? Z and k chala gaya, you're left with 1k, and here z and k both went outside, so nothing, 1. Okay. Now I still have square outside, so I took common from the bracket, put a box bracket outside, the whole thing ka square. Okay. So this also lies under square. जो common लिया है that also lies under square. So whenever you are taking common, take common and बाद में put a big box bracket and then square it. ठीक है? Or whatever the power is. Now over here also same thing. I can take z common. So taking z common, you are left with k and nothing over here, so 1. Now square है. So put a box bracket and square the entire thing. So now I can say it is z ka square, k ka square into k plus 1 the whole ka square. Okay, it is like a, b, c ka square. So whenever you have a, b, c ka square, you can square a, you can square b and you can square c, because there is into sign in between. So here I have into, here I have into. Okay, multiplication sign hai. Here there is no multiplication sign, so the square applies to the entire bracket. You cannot say it is k square plus 1 square. No. Okay, it will be k plus 1 the whole ka square. So when you are opening the box bracket, z का square हो जाएगा, k का square हो जाएगा and k plus 1 the whole का square हो जाएगा. ठीक है? So z squared, k squared and k plus 1 the whole ka square. Same thing over here. Z will be squared and k plus 1 the whole ka square. K plus 1 the whole square, k plus 1 the whole square, cancel हो गया. Z square cancelled. So you're left with k square. So we are not getting RHS directly. So what we'll do, mark this as 1 and let's check the RHS now. X upon z. X is what? Zk square upon z. Z cancel हो गया. You're left with k square. Mark this as 2. From 1 and 2 you can say LHS is equal to RHS. So from 1 and 2 LHS is equal to RHS. Therefore you write down the entire thing. This is equal to this, hence proved. Okay. Moving on to next question, question number 19. Given x is equal to square root of a square plus b square plus square root of a square minus b square upon square root of a square plus b square minus square root of a square minus b square, use componendo and dividendo to prove that b square is equal to 2a square x upon x square plus 1. In given part you have root, okay, square root, and in to prove part there is no square root. So we need to remove the square root. Okay. Now before that, check the terms. You have square root of a square plus b square, square root of a square plus b square. Same terms. Over here, square root of a square minus b square. Same thing over here. And check the sign between the terms, plus and minus. So when you have same terms, okay, and the sign between them is opposite, which property you can use? Componendo dividendo. Okay, componendo dividendo is numerator plus denominator upon numerator minus denominator. This entire thing is numerator, this entire thing is denominator. Same thing in LHS. Okay, simultaneously on both the sides. So LHS में Is there a denominator? Yes. When no denominator is given, it is 1. So it is x upon 1. Alright, so write down the given first. You're given x is equal to a square plus b square ka square root plus square root of a square minus b square upon square root of a square plus b square minus square root of a square minus b square. Now this is the given. You'll write down the given first, and in next step you'll write x as x upon 1. I'm writing over here only, but next step may express it in that form. Okay. After this we will apply componendo dividendo, because to apply componendo dividendo you need numerator and denominator. So there was no denominator given over here, so it is 1. By componendo dividendo, I'm not writing the full thing, you have to write down full property. Okay. By componendo dividendo, numerator plus denominator upon numerator minus denominator. Same thing यहाँ पे. The numerator, put brackets, plus denominator. And your numerator minus denominator. Okay, now we'll open the brackets. All right, put brackets, otherwise you will make mistakes in signs. Okay, and you will not get the proving part. So now we'll open the brackets. A square plus b square, and your square root of a square minus b square. All the terms here will remain as it is because there is plus sign in between, so signs are not going to change. Your numerator will remain as it is and the signs of denominator will change. ठीक है? Your minus square root of a square plus b square, minus into minus plus square root of a square minus b square. You cannot change the signs inside the root, but outside the root the signs will change. ठीक है? This was positive, this became negative, this was negative, this became positive. Now some terms are getting cancelled, ye and this, so we get x plus 1 upon x minus 1 is equal to square root of a square plus b square plus square root of a square plus b square. It is like square root of 2 plus square root of 2. What will you get? 2 root 2, है ना? So you cannot add the terms inside the root, but it is like root 2 plus root 2, you will get 2 root 2. So 2 root of a square plus b square, and over here root of a square minus b square plus root of a square minus b square. So 2 root of a square minus b square. 2 gets cancelled. So x plus 1 upon x minus 1 is equal to, we are left with root of a square plus b square upon root of a square minus b square. Now here we will square because we cannot solve further. Okay, and some of you might say you can take a outside the root, b outside the root. You cannot, because there is plus sign in between and here minus sign in between, so you cannot take square root. Okay, between the two terms there should be multiplication sign or division sign, only then you can take the number outside the root. Okay, so यहाँ पे already square है, but you cannot take the square root. So what we will do, we will square on both the sides. So squaring on both the sides, everything gets squared, entire LHS, entire RHS. So let's square on both the sides. So squaring on both the sides. So when you square, ये root चला जाएगा, यहाँ पे भी root चला जाएगा. Okay, because square and square root ultimately cancel out each other. Okay, so write down the numerator and denominator and whole thing ka square. It will not be x square plus 1 square, x square minus 1 square, no. Entire thing ka square, entire thing ka square. So whole square, and over here a square plus b square, the whole thing का square, upon square root of a square minus b square, the whole thing का square. So square and square root ultimately get cancelled and you are left with only a square plus b square and only a square minus b square. And यहाँ पे it is of the form a plus b the whole square. So you have to use identity. Okay, यहाँ पे identity हो जाएगा. So a plus b the whole square is a square plus 2ab plus b square. So it will be x square plus 2 into x into 1 plus 1 square upon x square minus 2 into x into 1 plus 1 square. A minus b the whole square, a square minus 2ab plus b square. Here we are left with a square plus b square upon a square minus b square. So we get x square plus 2x plus 1 upon x square minus 2x plus 1 is equal to a square plus b square upon a square minus b square. Cross multiply, put brackets and then cross multiply. ठीक है. So a square minus b square into x square plus 2x plus 1 is equal to a square plus b square into x square minus 2x plus 1. So opening the brackets, multiplying this term with the entire bracket and this term with the entire bracket. So a square into x square plus 2x plus 1 minus b square into x square plus 2x plus 1. Same thing over here. ठीक है, a square into the bracket and then b square into the bracket. So a square into x square minus 2x plus 1 plus b square into x square minus 2x plus 1. Opening the brackets, a square x square plus 2a square x plus, always write down the number first. Okay, 2 पहले लिख दो, a square x. I have written in alphabetical order. A comes first and then x. So I have written it in that order. A square into 1 a square हो जाएगा. Minus b square x square minus 2b square x minus b square. The signs will change over here because you are multiplying by minus b square. Okay. Is equal to a square x square minus 2a square x plus a square plus b square x square minus 2b square x plus b square. I can cancel out a square x square. This I cannot, signs are opposite. This I can cancel out. Again the signs are opposite. This I can cancel out. So we are left with 2a square x minus b square x square minus b square is equal to minus 2a square x plus b square x square plus b square. Okay. Now we need b square equal to this. Okay. यहाँ पे कोई b नहीं है and यहाँ पे there is b. So what we will do? All the b वाला terms we'll group on one side. All the terms that contain b we'll keep on one side and the terms containing a and x on the other side. So a and x वाला ये terms है. Okay. So these are negative. Let's shift this over here. It will become positive. Okay. And this we'll shift over here. So this 2a square x as it is. इसको shift करते हैं तो plus 2a square x is equal to b square x square plus b square. Okay. And shifting this over here, plus b square x square plus b square, the signs will change. Okay. 2a square x plus 2a square x gives 4a square x. B square x square plus b square x square, 2b square x square, and over here b square plus b square gives 2b square. ठीक है. Now I can take b square and 2 common. So let's take b square and 2 common from this. So this is what we have. Now we will take 2b square common. And in bracket we are left with 1x square and here nothing, so 1. Okay, now I have b square alone. B square alone है, so we'll keep b square as it is and rest all we'll shift on the other side. ठीक है, so we'll shift 2 also on the other side and x square plus 1 also on the other side. So 2 into x square plus 1 we'll shift, so it will go in denominator. यहाँ पे numerator में है, when you shift it will go in denominator. So because there is into sign over here. Okay, so 4a square x square is equal to b square, and shifting these two it will go in denominator. Okay, 2 2s are, and here you cannot cancel out, there is plus sign in between, so you cannot cancel out. Okay, so 2a square x square upon x square plus 1. So this is what we wanted, we got it. Let's switch the sides. Box this, hence proved. Okay, proceeding to next question, question number 20. If x square plus y square upon x square minus y square is equal to 2 1 upon 8, find first part x upon y, second part x cube plus y cube upon x cube minus y cube. Very easy. This is the given information. Okay, and we need to find x upon y. Check the terms of the given information, x square, y square, and the signs between them are opposite. So you have same terms, opposite signs. Which property you can use? Componendo dividendo. So let's apply componendo dividendo. Okay, so this is the given information. Okay, first we'll convert this to proper fraction. This is mixed fraction form. So 8 2s are 16, 16 plus 1 17 upon 8. Okay, now we'll apply componendo dividendo. Componendo dividendo states numerator plus denominator upon numerator minus denominator. Numerator is this, denominator is this. So by componendo dividendo, numerator plus denominator upon numerator minus denominator. Same thing, numerator plus denominator, numerator minus denominator. Opening the brackets, x square plus y square plus x square minus y square upon x square plus y square minus x square plus y square. Signs will change over here when you open the brackets. Minus sign है बाहर में, so signs will become opposite. 17 plus 8 25. 17 minus 8 9. X square, y square. So we are left with x square plus x square, 2x square. Y square plus y square, 2y square. I can cancel out 2 2. So we have x square upon y square is equal to 25 upon 9. Right? Now I need x upon y. So I don't want square. So we'll take square root on both the sides. So taking square root, we'll write full words, okay, on both the sides. So x square will become x, y square will become y. 25 का square root is 5 and 9 का square root 3. You will not consider negative numbers over here. We are not considering negative values, okay. So x upon y is 5 upon 3. In your textbook they have given in mixed fraction form. So let us express this in mixed fraction form. Okay, 5 upon 3 है. So you can write it like this or mixed fraction form. So you will divide 5 by 3. 3 ones are 3 and remainder is 2. Okay, so 3 will remain as it is, your 1 and remainder 2. ठीक है, so this is the answer. All right, Now moving on to the second part. We know that x upon y is equal to 5 upon 3. We need to find x cube plus y cube upon x cube minus y cube. This is of the form numerator plus denominator upon numerator minus denominator, right? Numerator is x cube, denominator is y cube. So you need x cube and y cube as numerator and denominator respectively. So I know x and y. I need x cube and y cube. So let's cube on both the sides. Cubing on both the sides. So you have to give reason, okay? X will become x cube, y will become y cube, 5 cube and 3 will be 3 cube. So x cube upon y cube is equal to 5 ka cube, 5 into 5 into 5, 125, and 3 into 3 into 3, 27. You're supposed to know the cubes and squares up to 30. Cubes, squares, square roots and cube roots. You're supposed to know these, okay? So this is the value of x cube upon y cube. Now applying componendo dividendo. It will be numerator plus denominator upon numerator minus denominator. Same thing in RHS. So by componendo dividendo you write the full thing, okay? X cube plus y cube upon x cube minus y cube is equal to 125 plus 27 upon 125 minus 27. So this will be 152 and this will be 98. Okay, I can cancel out by 2. 49s are 276 up, okay? So x cube plus y cube upon x cube minus y cube is equal to 76 upon 49. In your textbook again they are given in mixed fraction form. So you can box this, put an OR, express this in mixed fraction form. So 76 divided by 49. 49 ones are 49. So we have 16 minus 9 gives 7, 6 minus 4 gives 2. So 49 ones are and 27 is the remainder. Okay, so box this. All right. Here we did not consider mixed fraction, okay? Directly fraction ही ले लो. Even if you consider mixed fraction, again you need to convert it. So instead directly take 5 upon 3. All right. Express it in mixed fraction because यहाँ पे given is in mixed fraction form. That is why they have written these two in mixed fraction form. Also because numerator is greater than denominator, so normally we express in mixed fraction form. Okay. So both of these express in mixed fraction form.